going to find the equation of the tangent line such that it is the tangent to this line at this given point. And then we're going to use our calculator in two different ways to confirm our work. Alright, so if I want the equation of a tangent line, I need a point on the tangent line, which is great. I can use this point, even though this point is on this function, it would still also be on the tangent because the tangent is going to touch the function there. So I've got the x1, y1 part of my point slope form. All I need, so I can already plug in a 2 here and a 1 there. All I need to know is what is the slope of the tangent line. And the slope of the tangent line is going to change depending on which x value you're talking about. But we would then want to know derivative, because the derivative will tell me the slope for any value of x. And then I can go back and worry about the x value of 1. Now I guess before I'm ready to take the derivative on this one, I probably need to rewrite this one a bit. So 1 power, or 1 rule of exponents. This is like x to the third, and then a fourth root is like 1/4. So instead of saying the fourth root of x to the third, we can say x to the 3/4. And then I'm going to move all of this to the numerator, and since it's moving to the other side of the fraction, it's going to change signs. It's going to go from being positive to negative. And now after that rewrite, I can use the power rule. So bring the power down, lower the power by 1. Let's see, -3/4 minus 1 be -7/4. Okay, so this would give me the slope for any x. And just out of habit, I'd like to reduce this. I definitely want to reduce this. 6/4 will reduce to 3/2. And x to the -7/4, I'm going to move this back to the denominator and make it x to the +7/4 down in the denominator. So this will tell me the slope of the line for any value of x. Now I'm going to say, wait, I only really care about at this specific point. So when x is 1, and that would give me -3/2. You see 1 to the 7th power is still 1, and then the fourth root of 1 is still 1. So it looks like the slope at that point would be -3/2. So there's the equation of my tangent line at that point. Now, as I said, we're going to use our calculator to help us check some of this, and my calculator can't graph this for me. Calculator can only graph the y-equals, so let me add the 2 over. This is what I'm going to type into my calculator. Alright, so I'm going to want to graph two things here. I'm going to graph the original function, and this would be all of these are equal, so this would probably be the easiest way to type it in. So I'm going to do that. 2x to the -3/4, and we were interested in what's going on at the point 1, 2. So first of all, it better hit the point 1, 2. So trace 1, enter, allows you to jump to that, and so that does confirm it hits that point. So right here looks like the tangent line, and all of the work that I just did was to try to find the equation of this line that touches this function once at this one point at that one instance. So I'm going to also graph it. So we got this as a slope. And then I added the 2 over so that it was in y-equals, and it better be this line right there. And that looks good. So that confirms to me that that equation was correct. All right, another way we can use our calculator to help us check some of our work is we could have used our calculator to do this right here for us. We could have asked it to find the derivative for us at 1 and make sure that that is supposed to be -3/2. So how you would do that is go to your home screen, Alpha window to get the F2 menu, and we're doing a derivative, and it was a derivative with respect to x, and the function was 2x to the -3/4, and I wanted to evaluate it when x was 1. And so we were hoping this was -3/2 because that's what we figured out algebraically. And this is what my calculator is trying to say. You can see it's got a little bit of a rounding error with the algorithm that it uses, but it's trying to say the same thing, so that confirms that as well.